Hello, everybody. I got a question this week about domain range and intervals of increase and decrease, and I just figured I'd go over some problems similar to the worksheet we did in class to clear things up a bit. So to start, we're going to look at this graph on the right, and what we see here is a parabola. Um, Basically, what we'd expect is this is a y equals x squared sort of equation for this thing, and we want to find its domain, its range, its interval of increase, and its interval of decrease. Now, starting with domain, we need to remember that when it's looking for domain, when we're looking for a domain, what we're looking for is all of the x values. So remember that this is the x, this is the y. So we're looking for all of the x values for which this function actually exists. So for this one, we need to remember that this goes on forever in both of these directions. So it's going to exist at every x value at all of these points. We just can't see it from here. So by looking at this graph, we can pretty quickly tell that if this goes on forever and this goes on forever, then its domain is going to be everywhere. And the way we write that is negative infinity, comma, infinity. And this is inside parentheses because we never put brackets. We only put brackets when we're including a point. And when it's negative infinity and positive infinity, we're never including it because we can never get to infinity. So again, we're just looking at the x values. It exists everywhere for all x values just because it goes on forever, left and right. Now for range, we're looking at the y values. And this is a different story because while we can see that our equation exists at all y values from here up, below this line right here at 0, it doesn't exist at all. So what we're going to have to do is represent that in how we write our range. So the way we're going to do that is we're going to, we're going to put a bracket. We're going to see, I'm getting ahead of myself. We're going to look on our graph, what is the lowest point, the lowest y value at which our line exists. And we can see that it's right here at this point 3, 0. So with that in mind, we know that the lowest y value we get is 0 because it never goes below that. And we see since it's a solid dot that we're going to include 0 when we write our range. And when we want to include something, we use a bracket instead of a parentheses. So the way we're going to write this is bracket 0, comma, infinity parentheses. And that's because we're going from 0, which is the lowest it goes, all the way up to infinity because it just keeps going and going and going straight up forever. So that's how we can find the domain and range for this function. But how do we find the intervals of increase and decrease? So what this is asking us is to say, imagine, this is what I like to think, imagine you're walking down or you're running down the slope from left to right, just sort of the same direction you read words. And if you're going down, it's decreasing. If you're going up, it's increasing. So if we look at this graph, imagine we're like on a sled or something, we're going down, we're going down, we're going down, and now we're not going down at all. We're just staying still. And then we're going up, we're going up, we're going up. So it looks like anywhere left of this point, we're going down, and anywhere right of this point, we're going up. So for intervals of increase and decrease, we only write down the x values where they happen. So for the interval of decrease, remember that's anywhere to the left of this line. So this is decreasing. And anywhere to the right of this line, it's increasing. So to write anywhere to the left of the line of the point 0.30 for the decrease, we're going to put negative infinity, comma, 3. So as I may have said already, for intervals of increase and decrease, we only care to write about the x values. So this goes to the x value of negative infinity, and it stops at the x value of positive 3. So we just want to keep that in mind. Now, for the interval of increase, that's everything to the right of this point here, because that's when we're going up on the line. So we do the same thing. The interval of increase goes from 3, the x value of 3, to infinity, just because this graph keeps going forever. So hopefully that was clear. So let's move on to another example. I can get my PowerPoint to work. Maybe not. Ah, now I see. Perfect. Sorry about that. All right, so here we have another example. And to start, we're just going to go with the domain. And again, we're just looking at the x values here. Where does our function exist for our x values? And remember, this is just going on forever in either direction. And if we take a look at this, it looks like there's no holes or anything. There's nothing strange going on. It exists at every single x value. There's nothing missing. So for that, we're just going to put the domain is negative infinity to infinity. Simple enough. Now the range is a different story because remember, for range, we're looking at our y values. So where does it exist on up and down? So again, we can see that since it's going forever in the left and right directions, it's going to go up forever, just because this line will just go up and up and up and up and up. However, it does not go down forever anywhere because our lowest point is this line right here. There's nothing below that. So when we do our range, we know that the bottom, the very bottom, is going to be wherever this line is. And we can see that that point happens at y equals 2. So we're going to put that as our lowest point. And it goes all the way to infinity because it just keeps going up. And we use a bracket here because 2 is included in our range. There's no gap here. It's just from 2 up it exists. Hopefully that makes sense. So now we're going to look at the intervals of increase. So from here, we're going down. Past this point, we're just staying the same. And past this point, we're going up. So for our interval of increase, we're only looking at the part where we go up, which is any point past this line. So our interval of increase will be from x equals 2 to infinity. So this is x equals 2, just to remind you, and to infinity is just forever that way. The interval of decrease is right here, because that's where we're going downhill, looking from left to right. And that one goes from negative infinity to negative 2, as we can see right there on our graph, right on that point. Because remember, we're just coming from this way for infinitely far that way, and we just stop right here at negative 2. Hopefully that makes sense. Oh, I almost forgot. We also want to know, where is this constant? So let me put this here. Constant. And constant is where it just doesn't change. So in this case, well, let me slow down there. Where it wouldn't change would be right here, because it's not going up, it's not going down, it's just staying flat. So our interval over which it's constant would just be from negative 2 to 2, because those are the points that this constant section lies between. Hopefully that makes sense. All right, so let's move on. All right, this one's very similar to the last one. Again, we're going to look at the domain. Remember, these go on forever in both directions, so that'll be negative infinity. Oh, whoa. Infinity to infinity. Since it goes on forever in both directions, there's no holes or anything. Remember, that's the domain is x, the x direction, and range is the y direction, so up and down. All right, now for our range, we're going to look at, does our graph go up forever? In this case, it actually doesn't. This is the top of our graph. It doesn't go any higher than this anywhere. However, it does go down in other places forever. So on the left-hand side, it goes down forever. And on the right-hand side, it also goes down forever, as we can see. So we know that our range will be from negative infinity, because these sides are going down forever, to positive 2, because this line right here is at positive 2, as we can see right there. That tells us the height of that line. All right. Now we're going to look at the interval of increase. And remember, we're just going to imagine we're walking on this line from left to right. So from left, we're going up right here until we hit this wall. Then we're being constant right here. And then after this wall, we're going down. So for right here, this is where we're going up. This is our interval of increase. So that goes from negative infinity to infinity. And for intervals of increase and decrease, as well as constant, we always use parentheses. We never use brackets, just to make that clear. Now, we're going to try to find our interval of decrease, which again is right here because we're going down from left to right. So we're going to go ahead and write that as, oh, I'm sorry, it shouldn't be negative infinity to infinity. It should be negative infinity to negative 2. Sorry about that. And the interval of increase will be from 2 to positive infinity, because after this wall, we're going down. And this wall exists at x equals 2, as we see in that point. Finally, our constant exists right here, this middle section, and it exists from x equals 2 to x equals negative 2, that's this right here, to x equals 2. So we're just going to write that with parentheses, negative 2, comma 2, because that's where our line is flat. And that's what constant means. Hopefully that's clear. So let's move on to another example. All right, so this one's much more curvy. So let's see, we're starting with the domain. So the domain is all possible x values. Is there any point where there's a hole where this doesn't go to infinity, looking from left to right? Not really, because this side is going to go, this left side is going to go up forever, and this right side is going to go down forever. So our domain is going to wind up being from negative infinity to infinity. Now our range, I'm sorry, I meant left. This one's going to go left forever. This one's going to go right forever. For our range, it's the same thing, because this one's going to go up forever. This one's going to go down forever. So our range is going to be from negative infinity to infinity as well. Now our intervals of increase and decrease gets a little trickier. So again, we're just going to imagine where we're walking on this line, or if you're in a sled, and right here we're going down, 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 and we're still going down, down, down. We just go down the whole time. We never actually stop going down. It just changes steepness throughout. So our interval of increase, we don't have any. And there's a big interval of decrease because we're always, always going down. So that's negative infinity to infinity. All right, let's move on to the next one. Okay, now we're getting into things that are a little trickier. So this is a piecewise function. It's got a lot going on. So now we're trying to look for the domain. This is where we're looking for everywhere where our x values exist. So if we look to the left, that's going to go on forever. We can tell that it's just going to continue forever. So if we want to put that down right away, we can. So the leftmost part will be negative infinity. Now our x value keeps going, it keeps existing until we get right here. This is kind of weird, it throws us off. So does our x value stop existing here? Well, let's check. Nope, we just go straight down to here. Now, even though there's a hole at this point, meaning our graph is not defined there, it is defined up here. So we don't actually have a hole in our graph. It's just a big jump. So if these were both open circles, then we would have a hole at x equals negative 2. But since one of them is closed and the other is open, everything's fine. It's still defined. So that's fine. We don't have any holes yet. So we continue on. We continue on down this flat section right here. Everything's going fine. There's nothing missing, and we find a hole. Right here, we find another hole. But it's just the same as the last time. If we go straight up, we see there's a solid hole at this same spot. So there's nothing missing. Our function is still defined at x equals 3. It's defined right here, just not here. So, and then as we continue from here, it just goes on forever. So again, there's no holes. Everything's defined. So when we look at this, even though it has this big break in the middle, it's actually still defined for its x values everywhere. There's nothing missing. So our domain will be infinity. Now, the range is similarly difficult. So if we look at this, we can see on the left-hand side, this goes up for infinity, which is great. That makes perfect sense. And over here, this goes down for infinity. So we don't even really need to worry about this, because this right here will be covered by this. Because since this is going down for infinity, it's sort of like this. Excuse the poorly drawn line. We're going to have all of our y values defined going down no matter what. So we don't even really need to worry about this. However, we still have a gap in our range, which might be harder to see. That's because this line ends at y equals 2, and this line starts at y equals 1.75. So as we can see, there's this gap right in the middle here that's totally undefined for our y values. So that's actually the only point where our function isn't defined for the range. So the way we're going to write this is, the range goes from negative infinity to, so we're looking from here up. Goes from negative infinity to 1.75, and then it stops. There's a gap. So I'm going to write that negative infinity to 1.75. And since that is a solid dot and we're looking at range, we're going to put a bracket there because we do include that point. It's still there. Then we put a bracket, and now we're going to draw a union. That's what this is, because we're just jumping over this. We're just jumping over this extra section right here. And now we're going to start it back up again, at y equals 2. So now it goes bracket, because we're including the 2 again, it's a solid dot, bracket 2, comma, infinity, because it just goes on and on forever up here. Hope that makes sense. It's a bit trickier than the other ones we've done so far. All right. So now on to something hopefully a little easier. We're going to look at our intervals of increase and decrease. So we're just going to go down our graph from left to right. Here we are going from the left. We're going downhill, going downhill, going downhill. Huge drop. And then we're just flat. So we know that's constant. If it's flat, it's constant. Now we're going to go up here and going downhill, downhill, downhill. So there's never actually any point where we're going uphill. We're just downhill the whole time. So there's no interval of increase. However, what we did see when we were doing that is we're going downhill right here, and we're going downhill right here. This is flat. We're not doing anything. We're just constant. So I'm going to write the interval of decrease will be from negative infinity to negative 2, union 3 to infinity. So for intervals of increase and decrease, as well as constant, remember, we're only looking at the x values. That's why I put negative infinity is like way up here. Just imagine that goes on forever. And negative 2 is our x value where this ends. Now we jump over here, and our x value where it starts back up is 3. And then we just go on for infinity. So remember, when we're doing intervals of increase and decrease and constant, we use parentheses no matter what. So even though these are solid dots, we're still going to use parentheses because these aren't really increasing or decreasing, they're just points. So that's why we use the parentheses instead of the brackets. All right, and our interval of our constant, will just be this big flat line right here. So this goes from x value negative 2 to x value 3. So if we can just write that down. Negative 2 to 3. All right, so that's this one taken care of. Let's move on to the next one. All right, this is another tricky one. So our domain, that's the first thing we need to look at. So where on this graph are we going to be defined for our x values? So let's take a look. Going from left to right, we're up here at infinity. We're going to go left infinitely. You know, we just know that because this is going to go on forever. So our domain will start at negative infinity. We already know that. We always do with parentheses for infinity. And now we're just going this way, looking for any holes or gaps where we don't have a defined x value. Because remember, domain, we're looking for x values. And we see right here, we have an open hole. So that means we have a gap. Our domain isn't going to be infinity to infinity. There's a hole right here. So let's account for that. So this hole happens when x equals -2. So we go from negative infinity to -2, and we're going to use parentheses because obviously we're not including -2 because it's an open circle. Now we're going to do a union. And now let's look what happens after this point. We're going to keep going. Everything's fine. Everything's defined here. All right, so that's good. Everything's defined. And now, at this point, 2, we see that everything's still defined there. You know, we just make this jump, but there's no gap. We're not missing any x values. There's just a jump. So everything after that looks fine. It'll go on forever. So our only gap is at x equals -2 at this open circle. So from there, we just do -2, comma, infinity, because we start back up right after we pass x equals -2. All right. So now let's move on to range. So for range, again, we're looking at the y value. So this left-hand side, we can see that this is just going to go up forever. So our range will go up to infinity. We know that already. And we keep looking. Everything's defined for all y values. This little hole doesn't bother us because we're looking at y values now. And we still have y about the y value that would be here is defined over here. So we're totally fine. And we're looking, and there's a gap here. It looks like it could be a gap in our y values, but since we have the graph over here, that gap is accounted for, you know. The y values that would be here, they're right here. So if we look from down to up, we're always going to hit something in this region. However, below this region, we're not. The lowest point on our graph is going to be right here at y equals 0. So what we know is that at y equals 0, we're still going to include that on the graph, on our interval. And up, any y value higher than 0 is going to be defined. So that's to infinity, because if you just look, we always have a y value from here up. There's always a graph. If we look like this way, we hit a graph. Keep going up, we still hit a graph. Going up, we hit this graph. And then left, we hit graphs. No matter how far up or down we go, or no matter how far up we go from y equals 0, we're going to hit a graph if we go some direction. All right, so now we're going to look for our intervals of increase. So we're going to sort of walk along our graph from left to right. We're going downhill, 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 constant. And right here, we start going uphill. All right, so we know from y equals 2 to infinity, because this goes on forever, we're increasing. So 2, comma, infinity, we're increasing. Now, where are we decreasing? Well, from right here, from negative infinity to x equals -2, we're decreasing. We're just going downhill on this part. And then we stop decreasing and we're constant, and then uphill. So from negative infinity to -2, we're decreasing. And we're constant in this section right here, where it's just a big flat line. So we're constant from -2 to 2. And again, we always use parentheses for the parentheses for the intervals of increase, decrease, and constant. Always use parentheses. All right. So let's look ahead. Oh, and that's it. So thank you for watching. Please let me know if you have any questions. And yeah, have a good day.